Hello everyone. It's been a while since last time we talked about machine learning with Java. We went through deep learning for J, the Java open source deep learning library last time. So today we are continue to talk more about machine learning. So the title today I changed to deep learning, which is more suitable for our case. Deep learning with Java. And dataset is the topic we're going to cover today. The concept dataset is, so in machine learning or deep learning, when we do the model training, we always need a collection of data for training, test, even validation purpose. We are going to cover the following aspects. So what is dataset? As I just said, it's a collection of data for your model training, test, and validation. The basic operations include, let's say, usually the data will be coming from the internet or your data storage, for example, a database or some CSV files. We are going to show you how to load CSV data into a dataset. Normalization is another concept in the dataset preparation. We are going to use standardized or standardization as an example in our video today. After that, we usually need to split a dataset into two parts, one for training, the other for test. So in dataset split, we still need to do some pre-processing, for example, shuffling. So that the data in this set can be evenly distributed. I'll show you why we need to do that in our example. Okay, let's jump into the coding phase quickly. Okay, we're going to reuse the project we created in last video. I created an iris class here. Before we start coding, we need a dataset. So we are going to download the iris dataset from this link. You can also Google search and find this iris dataset CSV file. This is a very classic deep learning example. This is a classification case. I have already downloaded the data before the talk. So you can see this is the original CSV file. So there are 4 features and 1 label. The first step is to read the data from CSV file and import into a dataset. If we go to the POM, you can see I have already added a dependency to common CSV. This is for CSV parse purpose. So let's see, we can create a CSV reader class. The idea is that we want to get the records from a CSV file. Let's do this. CSV file. we are not going to catch any exception in this method. So we need a CSV parser. Looking into the signature, method signature, we need a CSV file, chart set, and the format. Chart set, for name, we have UTF-8. And CSV format, we can create a new format. This is to specify the limiter. Okay, this is a CSV parser. With this parser, we are able to get records. We return. Okay, we have a CSV reader now. So in Iris class, first step is to get the list of the records. The file, the CS file is in our main resources Iris data. Okay, we also simply throw the exceptions. So this is for the demo purpose. So we are not going to do the exception handling. Okay. So looking to the CSV file, you will see actually there are two, in my case, there are two empty lines at the end of the file. We need to do some handling in this record list. Before that, I think I can print the count, print out the count. I'll let you see what the total count of the records in the list. So you can see there are actually 150 valid records, but in the list actually there are 151 items. We need to do some filtering. We can do this string filter. For each record, we only accept size 5. That's because we have 4 features and 1 label. So we only accept the record with size 5. Now let's print out the record. Count of the record. Okay, 150. That's what we expect. Next step, we are going to create a dataset. Dataset is this is supported by ND4J. You can see from the constructor signature. This one is what we are going to use. 2 parameters. First one is the feature matrix. Second, the labels. Except in array type parameters. So we are going to create those parameters. How to do that? For features and the labels, so we need to fetch the features from the records and the same for labels. So we can do that by map. What are going to map? For each record, so we have 4 features. So here we can return double array r get new This is a string actually, so you need to pass it to double. The first four columns are features, so index 0, 1, 2, 3. This is what we are going to return. We can convert it to lambda expression. And we are not going to collect to list, instead to array. Okay, we need to give int function to the toArray method. Now we have a feature matrix. These are features. Next step is a label. For labels, you can see here in the comment, there are three types of three classifications in the raw data set in the CSV file. They are setosa, versicolor, and virginica. We do one hot encoding for them. For what one hot encoding is, you can search on Google, find some relevant documentation. The idea is that we want to use digits to represent the classifications. In this case, we say 001 for setosa, 010 for versicolor, 100 for virginica. So we need to do some mapping in our map function here. Labels. So we are going to do something like this. String comparison. If equals, okay, string label as get 4. So this is the label. If equals the label, return, what are we going to return? 001. Else, if it's versicolor, return 010 else 100. Okay, that's it. Okay, now I got two double type matrix, features and labels. Now we are going to create the int array type parameters for dataset. We say features array. So ND4J has a bunch of methods to create the array. We simply pass features to it. We got a features array. Now we need a labels array. Okay, we have the arrays. Now we can create a data set. Okay, we have the data set now. So this is how we import the CSV data into a data set. After that, we are going to split. We mentioned split the data set. So here, ND4J also gives you a handy method to quickly split the data set into training and test. Split test and the train. The parameter can be a double type fraction train parameter. We say 0.7. Okay, now we are going to get the train data set from the split and the test. Okay, now let's show you what it has in the train data set. Okay, let me print out the shape of the feature matrix in the train data set. You will see clearly what it has in it. Okay, that's wrong. So I get a train features matrix and the shape. Okay, you can see there are 105 rows in the features matrix. 4 features in each row or each feature input. This is what we expect as we split. We keep 70% of the 150 records in train data set, which is 105. Okay, we forgot one thing before split. We mentioned that we need to shuffle. Shuffle means we want to distribute evenly in the data set. Otherwise, the model cannot properly learn from the training data set. Why? Because you can see in the CSV file, all the Setosa classification data are in the beginning of the data file. Then it's a versicolor. Virginica is at the end. If we don't shuffle, the 17% of the training data set will only have iris setosa and the versicolor data in it. So the network won't learn Virginica classification in the training set. As a result, when you use a test data set against the trained network, it won't tell you or it won't correctly predict if it is Virginica or not. It will be pretty much a random prediction. So that's why we want to shuffle. Let's come back to the iris example. Now we have the data set. So we can create a neural network. Let's copy the configuration from the previous example XOR. We need to tweak a bit, but let's copy it. So first of all, we need to remove mini batch set. Instead, we specify the L2. This is a regularization term. For more details, you can also go to some deep learning courses and learn what the L2 regularization is. Okay, we also move the weight initialization to the global scope. So we are going to use Xavier, and the activation function we're going to use tangent. So we can remove the weight initialization and activation from the inner layer. We have 4 features, so input as 4. We set it to 3. The output. So we can also add one more intermediate layer. Correspondingly, we need to set the input neurons to 3, out 3. The last layer. So this is the output layer. We have 3 input neurons. Output 3 as we one-hot encoding. There are 3 output neurons. Okay, we need to remove the initialization. Okay, so this is how our neural network looks like. Now we can fit the dataset to the network. We use train dataset to fit. Okay, so now we can use the test dataset now to evaluate. We use evaluation class. So this is the number of classes. So how many classes are there in the data set? We have 3. Evaluation, we do the evaluate. Real outcomes is labels. And then we need to guess. How to guess? Output, we use a test feature. So this is a feature matrix in the test data set. We evaluate. Now we can print stats. Let's see the accuracy. Okay, you can see the accuracy is around 75.5 or 6%. The confusion matrix. Okay, so you can see it's not that accurate. So what do we miss? You may already notice that we didn't do normalization. So normalization is a key step that we can reduce the scale of the features. Okay, let's see what we need to do. Data normalization. As I mentioned, we are going to use standardization. FYI here, standardization is something like we have main value of the features and the standard deviation. So for each feature value, the standardization will do such calculation. So the standard deviation for mean, actually. So this is an algorithm to work out the standardized feature value. Now we need to transform so we need to fit with trained dataset. The normalization will work out the mean value, standard deviation for mean. It will remember, then we can transfer. So it will transfer the trained dataset by mean and the standard deviation. We do the same for test set. Okay. Done. Let's run the application again. See if it improves the performance. Okay, look. The accuracy is around 95%, and the confusion matrix is significantly improved. Okay, so that's pretty much for today. We have gone through the data set, basic data set operations, how we can load the data from CSV file into a data set, how to shuffle, split, and normalize. We also implement the basic implementation of classification network for iris dataset. We reached 95% accuracy in prediction. We split the dataset as a 7:3 proportion. Okay, that's pretty much for today. Thanks for watching. See you next time.